And yeah, now it's time for Terence to come to the stage. He is Heroku's Ruby, he's the lead of the Heroku's Ruby task force. He has worked on some OSS projects, so some open source projects you might heard of, like Ruby the language, MRuby, MRuby CLI, so small things like bundler rescue. And he likes Friday hugs, like all of us, I guess. And also, he believes in getting people together for Ruby karaoke. So let's give a nice welcome to Terence, and to you the stage.
Good afternoon. Got to turn this on. Nice. Happy Friday. Like I said, I like Friday hugs. If you've seen me talk before, you've probably seen me do one of these. And this is actually my second EuRuKo. So the first one I went to was a while back. So I'm excited to be back at another one. And this is a photo I took back then. And so I would like to continue this tradition. So I know you all just sat in your chairs, but if you could all stand up. If you're not familiar with Friday Hug, we essentially take a photo of people just like hugging, I guess, the camera. So do you want to come up and do the photo? So if you could all join me in doing a Friday Hug, I like to collect these as a memorabilia of this thing. Thanks for entertaining me with that. So my name's Terence. I go by Hone02 on Twitter. I'm mostly known for my blue hat, not really in the open source stuff, but I do have some blue hat stickers, so if you would like some swag, definitely come by and talk to me. I work at Heroku. Like they said, I work on the Ruby experience stuff with Richard Schneeman. Some of you might know him as well for some of his Rails work. But if you deploy Ruby apps to Heroku, you're using stuff that we work on. So if you have any problems with that, you should come talk to us about that as well. I did bring a few shirts and some stickers and iron patches and stuff for Heroku, but it's pretty limited, so come say hi, collect some Heroku swag as well. I live in Austin, Texas. We have really amazing tacos. If you are ever visiting in town, definitely reach out to me, and I'd be more than happy to take you out for some tacos. I run a conference called Keep Ruby Weird, which is also in Austin. One of my favorite things about the Ruby community is that we can do like weird, fun things like Friday Hug or Ruby Karaoke. And for those of you who are not familiar with Ruby Karaoke, it's what it sounds like. You just get together and sing with a bunch of Rubyists. Some of my favorite moments on the conference circuit has been going around with people like Charlie Nutter and watching him sing Shakira. He's actually a really amazing singer. I think I was talking to someone yesterday at the speaker dinner about maybe getting a crew together tomorrow after the conference ends. So if you're still around, you like to sing some tunes, we'll try to get a crew together to do some singing. So now that I'm done with the intro, let's talk about Kafka. So the agenda for today is we're going to talk about Kafka, talk about some design constraints and some terminology there. We'll show you how you can use Kafka from Ruby itself. We'll take a deep dive in a more concrete use case scenario with code that goes along with that. And then we'll kind of go through a bunch of other patterns of how it's being used in the real world for real production applications at scale. There won't be any code samples in that part, but it'll give you a sense of like how and what you can use Kafka for. So I remember like a year or so ago, I've heard of Kafka, but I had no idea really what it was, just that it was a buzzword and people talked about it. And so one of the first things I did was I went to the official documentation. It's an Apache project. And these are the first two sentences that you read in the introduction of what Kafka is. So it says, Kafka is a distributed, partition replicated commit log service, provides the functionality of a messaging system, but with unique design. And I remember reading this and having no idea what this actually meant, like some bunch of buzzword salad. And so if I was to sum it down into kind of 4 words, this is what I would talk about. It's a distributed pub/sub messaging system. So there's a lot of terminology and things that are similar to stuff like if you've used Redis before or Rabbit or AMQP. They all have similar things because those are all like messaging systems that also do pub/sub stuff. But with the unique design, Kafka has these kind of design constraints that it's trying to achieve. It needs to be fast, it needs to do stuff at scale, and it needs to be durable with regards to data loss and retention. And when we're talking about performance, this is a quote that a fellow colleague of mine, Tom Crayford, who works on the Heroku Kafka team, I was asking him what the performance of like a small Kafka cluster is. And he says you can do hundreds of thousands to millions of messages a second and process them on a small cluster. And as a point of reference, when you're talking about like AMQP, you're talking about tens of thousands of messages a second on a single instance. So with this small Kafka cluster, we're talking about an order or 2 orders of magnitude more throughput with it. But that comes with certain design constraints that we'll see how we can achieve that kind of stuff. So I don't know, how many are familiar with Skylight, the Rails reporting tool done by the Tilda guys? So this is a Rails performance monitoring tool, for those of you who are not familiar. And Kafka makes up a core part of their architecture for being able to deliver the product that they have. And when you're in this business of doing performance monitoring, you're collecting a ton of data, like a ton of metrics for the performance of your application, and they generate histograms based off that kind of stuff. So you need to be able to process all this kind of information. And so they use Kafka as the backbone to handle all this streaming data to then put it inside of Cassandra for actually those windows of the histograms that you're getting. And one of the other things that they like about Kafka is that it's one of the only pieces of their architecture that doesn't go down, like ever. And so you don't really want to be using a product where if their service goes down, you lose data, or you get some misrepresentation of the histogram because it goes down during the middle of it calculating that histogram window. And so one of the nice things about Kafka is even if the thing that is calculating your histogram goes down during the middle of that transaction, in Kafka, they have position data. So when it goes down and it comes back up, if it didn't commit that position because it didn't finish, it will just continue from where it started and then recalculate that whole thing again. So when you're using something like Skylight, even if their service goes down, you're not going to lose that data that they have stored there. So that's really a great reason for why Kafka fits this particular use case. And if we take a step back and start to look at the terminology things that we'll be talking about when we're talking about designing and building stuff in Kafka, it's very similar to a lot of producer-consumer stuff that we're already used to today. So if you use Sidekick on Rails, you're probably very familiar with this pattern. You have a bunch of stuff that feeds work into some data store, and with Sidekick's case, like inside of Rails, you're sending an email request for someone who's registering as a new user. So those would be the producers inside of Rails, like creating the work that you're putting into it. And so Redis would be like the Kafka cluster that's holding all this data. And then the consumers would be the actual Sidekick workers that actually reading stuff off this data store and actually doing something with that information. And so when you're actually putting stuff into the Kafka cluster, these things are called messages inside of Kafka. And the messages are actually stored as byte arrays. And what that means is that you can actually store any kind of data inside of the message. By default, you can just use a string, so you can have some type of unstructured data that can be any type of representation of anything, really. But most people probably want to use something more structured. So I think something like JSON or maybe message pack or any real format that you want to be using, as long as the thing that is serializing the thing into the message, you're able to deserialize that message later after the fact. And so we have this huge stream of messages because we're doing this high throughput stuff. These are organized into this idea in Kafka called topics. And so topics are just a feed of these messages. And these messages are split across multiple partitions. So you can have it replicate and distribute it across your cluster. So a single topic can have, in this case, we have 3 partitions, partitions 0, 1, and 2. And within each of these individual partitions, the order that the message comes in is the order that it's written in. So Kafka guarantees the order within that partition of the way those messages are stored. And since it is a commit log, it doesn't actually allow you to reorder any of the messages once they've been written. So you can only append them at the end, but this gives you some nice guarantees of what you can actually do with this data. So you can only write to the end of it, and you can't reorder it. And so if we go back to this picture, it means that we can find a particular message by looking at the offset of where it is from the start. So we can easily read through this thing or start or replay any data by knowing the offset positions of where they are in that particular position. So this is something that the Skylight team uses when they're calculating those histogram windows. So as those messages are distributed across the various partitions, by default, they're just randomly distributed evenly across all the partitions that you have. You can actually set a key for a particular message, and that will guarantee that that message goes to, all messages that share that key go to a particular partition. So on the consumer side, you can actually do some nice optimizations because you know that you might get multiple keys for that consumer, but you know that all the keys that are coming in for, say, like user ID 12 are definitely going to this consumer. And so you can do some nice optimizations in memory or calculations that way. And then on the consumer side, we actually have this concept in Kafka called consumer groups. So you bunch a bunch of consumers together as a consumer group, and that allows you to scale on the consuming side the work that you're doing. So if we look at this picture, we have 2 consumer groups, consumer group A and consumer group B, and we have this Kafka cluster of 4 partitions, P0 up to P3. And so each consumer group can subscribe to a topic. So let's say consumer group A and B both subscribe to some topic A, or topic X or something. And so that means that they will both receive all the messages from that topic as they come in. And so the nice thing is within a certain consumer, all the partitions are then split evenly across the consumers inside of that consumer group. So in consumer group A, C1 takes partition 0 and 3, and then consumer 2 takes P1 and P2. And they're both getting all these messages. But if we scaled consumer A to be like consumer B and we added 2 more consumers, Kafka will automatically redistribute the partitions so they're evenly split across all the consumers in that consumer group. So it will actually look more like consumer group B, where each of the consumers in it will only be handling 1 partition at a time. So as you can imagine, it's pretty easy to then scale up a Kafka cluster to be able to consume as you have higher throughput. The nice thing is that the inverse is also true. So if consumer, say, 6 drops in consumer group B, there's actually a heartbeat system built into Kafka that will detect that, hey, I can't connect to consumer 6, so I will stop actually giving partition 2 out to consumer 6, and I will put it on some other consumer. So you can not only get this like scalability elastic effect built right into Kafka itself, which is really nice. So when we're talking about distributed systems, we have to talk about how messages get delivered because of CAP theorem and other things like that. The ideal case that most people want is not any of these 2. What you actually probably want is that you want to guarantee that a message is delivered once, and you want to be able to guarantee that. But that's pretty hard to do in a distributed system. And so what Kafka does is it gives you the option, but by default it does at least once. And so like the name says, it means that it will if you subscribe to a topic, it will deliver messages from that topic at least once to that consumer group. But if there's any faults that happen throughout the thing, it may deliver messages more than once. So you have to have the ability to do duplication detection and not be able to do things more than once if that matters. Maybe if you're doing some cache calculation, that doesn't matter, but say you're handling credit card transactions, you don't actually want to bill someone more than once because you happen to get a message twice. On the other side of the spectrum, you can do at most once, which means you will only try sending a message once, and it guarantees that you will not get duplicates, but it does not guarantee that you will actually get every message. So those are kind of the two ends of the spectrum. And most people, I think, go with at least once and try to do some duplication detection. And so with that, with the messages and topics and things like that, with Kafka, we're able to, within a partition, guarantee that the messages that are put in order are actually written in that order. And so when we consume those messages, we can actually consume them in that order, and that the topics are distributed and replicated across our cluster. So if any of the nodes go down, we still have access to those messages. So now that we have some understanding of what Kafka is, like how do we actually use it inside of Ruby itself? So one of the oldest Kafka libraries out there is JRuby Kafka. And what this is just a simple wrapper around the official Kafka libraries. Kafka is written in Scala, and so with JRuby Kafka, we can actually just leverage the official libraries that they're using. The downside of that is you have to be pretty comfortable reading Java API docs, which I think given enough time is not too hard. But probably the biggest deal breaker for most people is that if you have an MRI app, it's potentially a lot of work to convert it to JRuby just to use something like Kafka. Or it may not even be feasible because you might be using some native C extension that may not port over super well to JRuby. So I didn't really want to go into too much detail with JRuby Kafka. Luckily for us, Zendesk has been working on this Ruby Kafka library, which allows us to actually build stuff both in JRuby or MRI and actually leverage Kafka. There's an older Kafka library called Poseidon that only supports Kafka 0.8. The latest version of Kafka is 0.10, but Kafka 0.9 introduced a bunch of new APIs on how we consume stuff with consumer groups that it doesn't support. It doesn't even support consumer groups at all. You have to use a separate plugin. So we'll be focusing on Ruby Kafka because it supports the 0.9 APIs, which are much nicer and better than the 0.8 stuff. So with Ruby Kafka, in order to do a simple producer to put messages actually in the Kafka cluster, we need to initialize our connection to Kafka, and it looks pretty similar to a Redis connection or anything else that you're probably using in Ruby. One of the things to note, since we're talking about a cluster, is that you need to pass it a set of seed brokers, which are initial instances that you want to try to connect to. And once we've connected to one of those, it can then give us the rest of the network topology of where all the machines are. So you don't need to know what the whole set is, but you probably want potentially more than one in case one of those goes down and you need to connect to something else. Once we have that, we can actually just call producer, and this will make a synchronous producer that we can then use to send messages into the cluster. So we just call produce, pass it whatever we want for the body. In this case, it's just a simple string, and then we need to specify what the topic of how we organize this message. We talked about keys earlier, so this is how simple it is to then key a message. If we really want, we can manually decide what partition that this particular message goes to, so we can just specify that here as well. With all that, we can call this synchronous blocking deliver messages call, and what that does is it will take all these messages that have been buffered and actually send them out. And since this is blocking, it will only return once it is either failed or been successful. If it has failed, it actually raises an exception. And so with that exception, we can choose if we want to do the at least once or at most once delivery mechanism. So we can catch the exception and then deliver all the messages again, or we can just ignore it and then keep moving on. But you probably don't actually want to be doing synchronous work inside of a Rails process if you're producing this kind of stuff. That's going to block that web request, and it's going to take a long time for it to return. So the library supports an asynchronous producer, and we're able to pass in basically various thresholds of how long we want to wait until we actually send the messages. In order for Kafka to get the performance levels it does, it needs to buffer the messages so it's not continually hitting the Kafka cluster. And so we can specify either a threshold of how many messages we want in the buffer or how long to wait. And if we specify both, it will trigger when the first condition gets hit. Here's an example of how you can very easily serialize data into the Kafka cluster. So this is an example of taking a simple Ruby hash, dumping into JSON, and then putting that into the Kafka cluster. And then on the consumer side, we just need to be able to call JSON.parse on the message value. So in order to use this inside of Rails, it's pretty simple. You just have to do all this stuff inside of an initializer. So let's instantiate a connection to Kafka, pass in the seed brokers. We can pass in the Rails logger, so all the logs from the Kafka producer actually gets sent to where all our standard Rails logs go. From there, we want to make an async producer, and this is probably the important bit that I didn't talk about, is that you want to make sure you shut down your Kafka producer at the end, so you're not leaking connections, and the Kafka cluster doesn't think you're holding open connections to it. So make sure to add this add exit call inside the initializer. And from there, we can start sending messages inside of Rails. So here's an example of an orders controller of how we're going to create orders inside of Rails and then send them into Kafka. So we take an active record object, convert it to JSON, and then assign it to some topic and send that in. If you're doing this, you probably would potentially also have some foreign key from order that is associated with the user ID. And with that, we can actually key the Kafka message with that user ID if we potentially wanted to make sure all the messages for that particular user ID for that order end up on the same partition. So pretty easy to be able to use this stuff inside of Rails with this producer. So the next part is you need to be able to actually do something with the messages inside of Kafka. And this is the part that is where the new APIs from 0.9 are. And the Zendesk library marks this as alpha. So they make the claim that they might change the API sometime in the future. So this is something to be wary of, but the API is actually pretty good for doing real work. So there's a bunch of different APIs that you can use that they have, but the main one that I'll be talking about is the one with consumer groups, because I think that's the best way to consume stuff inside of Kafka at scale, because you want to be able to add stuff to consumer groups and be able to process those messages and be able to scale up those processes if you need it. So we instantiate Kafka like before. With that, we just call consumer and pass it a group ID. And the group ID is just some name that we're going to associate with it that usually describes the type of work we're doing. So that could be maybe log archiving or metric analyzing or some billing thing, right? And then we can subscribe it to as many topics as we want to get messages for. So if you have 2 topics, you subscribe it to those 2 topics that you can get the messages for, and then that consumer group will get all those messages. And each message here is actually a blocking call that will go through, and it will block and poll for messages, and as it gets them, it will then process the code in the block, and we can access the various things like the value, which is the body of the message, the key or partition, and things like that. So that's pretty simple on how you can create a consumer and actually use the messages that you're putting inside of Kafka. One of the new features inside of Kafka 0.9 is that it supports SSL now. 0.8 did not. So this makes it pretty easy to actually secure the connection if you don't have Kafka on the same machine as, say, your Rails app that you're using this with. It allows you to secure those connections. So it's nice that the Zendesk library supports that out of the box. So the demo app that I will be walking through is a metrics one. And what this is we'll be building metrics based off of the web traffic. So per path, we'll be calculating like the service time, how long it takes to service the request, what the status code is, and things like that. And we'll be using Kafka to basically hold that stream of data in case it's high throughput, and then storing it some type of data store. So here's that architecture. We have some main app. It gets a web request. We take those logs of the routing data that we care about. We pass it to the metrics app, and then we store that data, like I said. And if we're to drill in a little bit more, the example app that I'll be using is Code Triage. I don't know if people are familiar with it, but Richard built this app as a way to get involved with open source. So if you sign up for it, you can sign up for particular repositories, and it will basically message you like an issue a day to basically check in on and respond to help maintainers maintain open source. So this app is a Rails app that's hosted on Heroku. It's open source. And with that, we're able to take those router logs and build a Ruby app that is then able to produce the messages that get sent to Kafka. And once the message is in Kafka, we can then build another Ruby app that will consume those messages and aggregate the data and store them inside of Redis. And then once it's in Redis, we can kind of do whatever we want with it, right? Like it's pretty easy to access Redis inside of Rails. You could build even like a Node or Go or whatever app that interfaces with that Redis data store. We're not going to walk through the Rails part of that because it really doesn't have anything to do with Kafka, but I think it'd be pretty simple for anyone who's dealt with Redis to be able to do stuff with that data. Maybe build like a dashboard, some visualization layer, or what have you. So first looking at the router logging, how we're going to get this information. If you've used Heroku before, you've probably seen a bunch of these, but these are basically, here's a single router log that we get when we get a request into a Heroku app. And there's a few pieces of information on here that make it useful for us. So the first one is we can find the path that is being requested. So we have that path to kind of use as a key for associating metrics with, right? Like we want to know the metrics per path and not necessarily across the entire app generically. We want to know the connect time, which is the time it takes for the router to connect to your dyno for this request, and then the service time, which is the time the dyno takes to actually service that request. And then we can also even get the status code, which is, did this actually return successfully? Is it a 200? Did we get a 500? Was it a 404? Things like that. So with that, we can actually calculate the count of what are the number of successful requests we're getting for this actual route. With that, on Heroku, we can actually just add a HTTPS drain, which basically just sends all this logging data, and then both the router and everything else, to some type of endpoint we have out there in the universe. And so in our case, we're going to host another app on Heroku that's just going to take that data and then put it into Kafka. And this is what the post request body looks like. So it's just a collection of these log messages, and as one of the headers, it will actually tell you how many of these messages are in a single body, so you can cleanly parse that information. One thing to note is that RFC 5424 is the syslog RFC, and that the Heroku syslog is not actually completely compliant because we leave out this structured data thing. But luckily, inside of the Ruby world, we have libraries that can take that into account and still parse our stuff fairly easily, as we'll see. So now that we understand like what kind of data we're dealing with from the request, like let's take a look at an app that actually takes that data and processes it. So this is the producer part of the Kafka architecture. So we can have a simple Sinatra app that takes a post on a process. If you've done Sinatra before, this is probably pretty simple and what you've seen before. We're going to return a 202 because the messages may not be delivered immediately, so we want to just tell the client that we've gotten the message and we've accepted it, but may or may not have finished the request. One thing to note is that the Kafka producer is not thread safe, so that means that you can't actually share a Kafka producer at the same time across multiple threads. So we're going to use Mike Parent's connection pool to ensure that a producer can only be used by a single thread at the same time. So inside that process messages method, we can basically take that body text, chunk it into basically an array of messages that we can then send into Kafka. And so we check out a producer from the connection pool, and then this should seem pretty close to the really early example code that I showed of how you send messages to Kafka. So since we have an async producer, we don't actually need to call deliver messages, and then when it hits that threshold, it will actually go ahead and deliver those messages for us. So let's talk about the Kafka cluster itself. So I think Kafka is great, and that's why I'm talking to you about it. But I think one of the most annoying things about Kafka is actually running it as a service. But it's an open source product, so you can go ahead and run it. You have to run a cluster. It uses Zookeeper for configuration, so it can sync all this information across all of the nodes that it's running. But if you're in the Ruby ecosystem, you may or may not be super familiar with the JVM technology and how to operate and run those services. But you can go ahead and go do that. So Heroku is actually, we're starting to launch a Kafka service. It's in early access. I think it's GAing pretty soon. And we want to basically take the pain out of running. If you want to use something like Kafka, like going ahead and running all that stuff, like the entire JVM stack, running Zookeeper, making sure it doesn't go down. And since it's just a Heroku add-on, you can go through and just create it like any other add-on. And since it's creating a cluster, it actually takes a while to spin up all these machines. So we have the Kafka wait command. So when that returns, your cluster is actually up and running. And then we provide you some MVARs like every other add-on that allows you to easily connect to your Kafka cluster with SSL, because you want to ensure that that data is encrypted across the network. With that, you'll need to install the Kafka CLI plugin, which gives you access to the Kafka namespace on the Heroku CLI. And this allows you to actually do things with Kafka itself. So by default, when you're developing with Kafka locally for stuff, it configures it so it auto-creates topics for you as you use them. But you probably don't actually want this setting for production. So at Heroku, we turn this off. So you need to use this Kafka Topics create to actually create this router topic that we're going to be using. But if you're setting this up yourself, you could just make sure to either not set that thing off or to make sure to actually create it so Kafka knows about the topic. And the reason for this is, like, if you are doing something in production, you probably know all the topics that you're going to be using, and you don't want some typo or something else to actually insert stuff into a topic that you may not even realize is an actual topic. You can do things with the Kafka plugin, like inspect your Kafka cluster, see what version you're running, see how many topics you have, see like the network throughput, how many consumers you have attached to it. You can even inspect an individual topic, so you can see how many partitions are actually created. So this kind of limits you on how many feasible consumers you can have in a single consumer group. So by default, you get 32, but you can increase that to even more if you wanted. And then similarly, you also have this tail command, like the logs tail command. So you can actually see the messages and tail a particular topic and see them come through. There's a bunch of other stuff inside the Kafka namespace plugin. Like you can write to a particular topic, like you can do test messages or actual messages by hand without having to programmatically do that, as well as configure a bunch of stuff that fit your specific needs. Now that we actually have a running Kafka cluster, whether it's on Heroku or you've done it yourself, we can look at the consumer side of that application. So with that, we have, we're calculating these metrics. So we have this metric consumer. We're going to call the group ID metrics, not very original. And then we need to subscribe to that router topic that we created earlier. And with that, we can actually pass in where we want it to start when we initially connect. So this is the default offset. So by default, it actually sets it to latest. So it means that it will just pull the latest position and use that of whatever was last committed. And if you don't have an offset that has been committed, it will start with whatever the latest actual absolute position has been in the queue. But since we're kind of dealing with cache data here, like, I didn't think it mattered that much, but you can obviously fine-tune this depending on your use case, like the Skylight people have. We need a connection to Redis because that's where we're storing stuff, and then we're basically going to go through each of these messages and then parse, deserialize that JSON that we put in initially, and then with that data, we can insert the stuff that we actually want to inside of Redis. So here's that insert code. It's not very important, but basically we're calculating the average of the service and connect time. We're keeping track of the number of status codes we're getting per route. And so since we have all this stuff segregated, it should make it very easy for a simple Sinatra Rails app to pull this information out of REST and actually do something very useful with it. So that's a single consumer group. But one of the nice things about Kafka is that you don't really need a lot of coordination between the producer and the consumer besides kind of the serialization and knowing what's being put into it. So if you had, say, a separate team that wanted to do something else with it, in this case, it's probably the same team here, but I have this replay consumer here. And what this does is actually takes those router logs and does something completely different with it. So I'm going to get all the same messages that the metrics aggregator is getting, but I'm going to do something else with it. So I'm going to parse out the path that I have, and I'm going to basically replay this traffic against a staging app that I have up and running. And so that's pretty easy to set up with a complete separate consumer group inside of Kafka. So here's the code that does that. We give it a different group ID because we don't want it to be part of the same group. We have to tell that consumer group to subscribe to this topic, and then we're just making HTTP calls based off of the path inside that message from the router log. And then we're going through and doing that stuff. This was built in JRuby to basically be able to get some really nice concurrency with that, but you could obviously build an MRI or something else. You could probably even do it not in Ruby if performance was a particular concern. So all this code is up on GitHub. You can go here to this repo, download the code, and play with it and examine it in more depth. And I set all the stuff up with Docker, so you get Redis, you get the entire Kafka cluster, you get all of the JRuby stuff all set up, so you don't even need to have any of that stuff locally. You just need to have the Docker tools set up, and you can get all that stuff spun up with this single command. So let's talk about some other patterns that we can use with Kafka itself. We're talking about a messaging system, so using it for messaging is probably an obvious use case. A particularly good example for this is any type of high trade financial transaction system would use something like this. If you're talking about stock trades and things like that, you probably don't want to be losing any of that data. So the durability guarantees that Kafka gives are really nice. Trades happen at a pretty fast rate, and you want to be able to have that low latency to be able to do stuff very easily with that data and quickly and provide that to customers. And you're having a lot of it, so you need that throughput, that big pipe of being able to handle that kind of traffic and not have it fall over. The original use case for it was activity tracking. And so Kafka was created originally by LinkedIn to solve this problem where you go around doing stuff on the LinkedIn page, and you want to be able to see what people are doing. So you can create a topic per activity that you care about and then track that through Kafka. And so you can have various groups within your organization, like say a recruitment team that goes and subscribes to the topics that they care about and do stuff there. Or you could have, say, the personalization or recommendation engine probably do something similar. And I don't exactly know what Shopify uses Kafka for, but I imagine for some e-commerce type of site, like activity tracking probably makes a lot of sense to be doing stuff with Kafka, and I know they're using it in-house there. We use it heavily in-house at Heroku as well, so if you've been to the dashboard and you use our metrics, we have all these, like the memory usage, the response time, and things like that, and that's actually all powered by both Kafka and Postgres. So if you can imagine like running millions of apps on all these dynos and collecting all this kind of information is a ton of data to deal with, and Postgres really just can't handle that pure throughput of data. So we use Kafka as this stream to basically handle that kind of load. And then basically we take windows of time and calculate the information that we need and put them inside of Postgres. And then from within dashboard, our metrics team is able to then take that data out and display useful information to you. So similar to this is what I based the example app on, but this is a more actual complete use case. And this was built by only 2 people originally, and it works pretty well. The other final example that I have is the Heroku API Event Bus. And so as you're doing stuff in Heroku, you're interacting with the API, whether it's through the tool belt or calling it directly. You're doing actions on Heroku like scaling dynos up or creating add-ons, scaling dynos down. And as you can imagine, the ordering of those events are pretty important if you're, say, the billing team, because you want to bill people properly in the order that those messages come in. But what's nice about the event bus here is that many teams at Heroku want access to this kind of information. So both the billing team want to be able to know when you create an add-on, but the data team that we have that actually runs Kafka and Postgres and all those services probably also cares specifically if you create a data-specific add-on. So without coordinating with each other, they're able to consume this event bus and actually do what they need to and get their job done. And I think currently today we have 13 various teams using different parts of the event bus, and they're not all consuming all the messages. So I hope this talk has given you some insight in what you can do, the kind of applications you can build with Kafka. And I think Rails is in a place today where it's part of a bigger critical path for a lot of businesses, where it started maybe like 5 years ago with a Rails app. And I think things like durability, scalability, and speed matter now more for these kind of apps. And I believe technologies like Kafka that have been kind of started in the, even though it started in the JVM ecosystem, can be really helpful for us today, where you may have had problems doing stuff and scaling things with Redis, but maybe Kafka is able to solve some of those problems for you. So that's kind of all I had, and the organizer is telling me I'm out of time, so thank you. I will be around till Sunday, so if you have any questions, please come talk to me and then come get swag.
Thank you, Terence. So yeah, you can grab him here at the stage if you have some questions for him.